Hello, everyone. Would like a confirmation that I'm audible. My screen is visible. Yeah, I'm visible too. All right. Yeah, that's good. The session is being recorded, and whoever attending the session, they will get the recording. I guess this is also streamed online. Let me check. Yeah, it's also streamed in LinkedIn and YouTube and Facebook. So anyway, you will get a recording from there. All right, good. um, I would like to thank everyone attending the session. This is on data science versus data analytics. And my name is Ashok Veda. I'll be the host for this bootcamp. Before we move forward, a very quick introduction of myself. I'll share my LinkedIn profile. Okay. The net seems to be slow. Let me see if I'm connected to the right net. Yeah, okay. Seems all good. All right, so whoever is attending directly from the Zoom, I have a few hundred folks on the Zoom directly, apart from who are attending on the online, LinkedIn and other channels. So you could type in Ashok Veda, you'll find my resume, my LinkedIn profile directly. So I have about 20 years of experience in the industry, out of which 15 years into analytics. In fact, last 6-7 years, I've been working as a founder and CEO for Rubix, which is a mid-sized company, about 50 employees. We work on AI and ML solutions. So we have large-sized companies, Fortune 100 companies, Dell, PayPal, Cisco, as our major clients. We provide AI and ML solutions. Right? We also work on many proof of concepts with many research centers across the world. Predominantly in Europe is where our customer base is. My net is not stable. Yeah, that I figured that out. So let me know if I'm not audible. Can others confirm? Am I audible? Am I visible? Is my net is all good? Okay. So somehow there is a little bit problem with internet in the office today. So if you have any issues, if you're not able to hear me, just ping me so that I can repeat the topic, right? Okay, thank you. So you can find my brief. So I'm an engineer by background and also a MBA graduate from IIM Ahmedabad in India and University of Amsterdam from Netherlands. I started my first venture in 2009 in Netherlands, Amsterdam, called as Sportsquare, which is into providing sports analytics to amateur clubs, along with two of my co-founders, a senior colleague, a German senior colleague, and a Dutch colleague of mine. So I've been in Netherlands. I also work for Logica. Now it's a part of CGA for about 5 years. We are into providing innovative solutions. Mostly I work in smart city and analytics solutions. I'm also into teaching, coaching. I work with several companies, including DataMites, Accredited, Great Lakes, and many other companies, large-size edtech companies in providing AI and ML solutions. I've been a lead mentor for them for the last 5-6 years. Right. I'm also a researcher in AI. So I work in marketing vertical, consumer behavior using artificial intelligence. I also started a new venture in cybersecurity called as Digit Defense, which is into cybersecurity solutions for small and mid-sized companies. So this is my profile, and to put it in a simple way, I'm a researcher, practitioner. I teach as well deliver AI and data science solutions. So in this bootcamp, I'm going to specifically focus on data science versus analytics. I've been working in analytics for like 15 years now, and the past 7 years, I'm working on AI, ML, data science solutions. I've seen the transition from analytics to data science as an industry, as well as how relevant data analytics is right now. I'm gonna have this I'm gonna talk about from a career perspective. So I assume most people who are on the call are looking from a career perspective, right? So which is better? Is it data science or analytics for your career, right? So I'm gonna fine tune this webinar mostly from a career perspective. Okay. If you have any questions, you can ask these questions on question and answer section, right? Chat box is also okay, but it's difficult for me if there are too many chats flowing around. So it's better to put it in Q&A section. If you are in other channels like LinkedIn and YouTube, I would request you to put it in the comments. One of my team members will copy paste it over here for me to answer that question, okay? All right, so let's get started. So this bootcamp, we're going to look at what is data analytics and we look at what is data science. And of course, we compare them both from many different perspectives, skills especially. And of course, one of the important point of this bootcamp is which is the better choice. Well, it really depends, and we will explore the depends in more detail in a different context. And we take about 10 minutes at the end to answer any specific question answers you have, right? Okay. Before we jump into what is data analytics, I would like to take a very quick example to even establish what's the goal of data science or data analytics, all right? Let's take a very quick example. This is example I often use. This is a simple example of a restaurant business. So let's assume that you have been running a restaurant business for 1 year. Okay. And now you want to decide whether to expand this business to the next level. Second, essentially a second outlet and a third outlet or a branch of your restaurant, expanding your restaurant business, right? So because you have 1 year of experience, you would have known a lot of things about this business, right? Which will help you to really decide whether to expand or not. To give you a quick information, let's say you have been making significant loss. This 1 year, you will end up making a lot of business loss. Would you expand the business? You can answer it in the chat box. It's actually quite simple. If you make a significant loss, it's a simple restaurant business. I'm not talking about IT where you really focus on customer share, market share. That's different. So it's just simple restaurant business. If you make loss, you don't think about expanding it, right? You should figure out why are you making the loss. What are the other factors you actually consider? Loss is one, which is, of course, pretty straightforward one. What are the other factors you consider when you're expanding a business? Profit, yes, that's right. Gross profit, yes, Ranjit says gross profit, Hansi says profit. Customer base, Nirmal, that's right. Growth rate, that's really good. You have to see the growth rate, right? Market reach, do you have business, more business? And how much market you're able to reach? That's very good. Anyone talking about even simple things? Like one of the very important things which reflect your business success. Key points, expansibility, raw material, location, yeah, value, goodwill, okay? But there's one thing which most of you are missing, really simple one. Money, of course, data, of course, everything is coming from data, quality, growth. All right. Oh, I still didn't see the answer from the comments. That's really interesting. Anyone talking about customer feedback? Isn't it important? It is, right? So nowadays it's all Google Maps, isn't it? Feedback. So if you have, I don't know, let's say a lot of things, customer feedback is here, right? So if you get a customer feedback of, let's say, 2.1 star out of 5, of course, right? Some about, let's say, 500 people have given this. Would you expand? Assume that you're making profit, you are good. Would you expand? You're getting 2.1 star. That sounds like a really poor rating, isn't it? Another side, if you let's say if you have a 4.7 star, about 1,000 people have given it, plus you have made significant profit, would you expand? Yeah, of course. You're making profit and customers are happy about it. It's simple, right? So these are extreme cases, right? I mean, this is something which you don't really need to do a lot of analysis. If you're really doing bad, you don't expand. you're doing exceptionally good, then of course you'll expand. But most of the business are somewhere in between, right? So you consider all the factors, right? Customer preferences, popular recipes. There's a lot of other factors which is missing here. How many times they're coming back to your restaurant, turnaround times and stuff like this. A lot, many things. I have one quick example here. I want to see how many of you answer this correctly. I have two scenarios, restaurant A and restaurant B. Okay. And restaurant A has a sales or revenue of about $3.6 million. This is for the first year. It's the same example. And then they made a profit of $2.5 million. If you would like to calculate a profit margin, essentially profit by sales, it's 2.5 by 3.6. If you're good in math, you should do it fast. It's roughly around 70%. Slightly less than 70%. And in this case, the profit margin, they made a sales of $2.4 million and profit of $1 million. If you look at the numbers, it's definitely less than 50%. I think it's roughly around, it's even less than 45%. Okay. A very simple question to you. Which company would you like to expand? Which restaurant business? Is it A or is it B? Okay. It's not a tough question, is it? So it's everyone says A, right? Someone says both as well. And see, that's interesting. But it's not tough, okay? It's not tough at all. Well, just waiting for everyone to. There are 3-4 members talking about both. We have nearly 200 participants on the call. A smaller percentage, still there is some percentage. Good. Well, I would like to also look at monthly sales. I said 1 year, right? So it's January to December. So I would like to also, because we have the data, so we can actually look into the monthly sales, right? Monthly sales is the same sales, but it gives you more information. So if you look at the monthly sales of, this is your sales of restaurant A, this is January to December, right? If you calculate the average per month, it's 3.6 million. So by 12 months, you get 0.3 million as your average. So this is your average point. Now you look at that. Are we doing good? By the way, is restaurant doing good? A, doing good? No, it's not doing good, right? Initial days, yes, few months, there was a very good sales, but then it gradually fall, right? From June, it was like really low, and then it's really falling. There might be some attempts they have done to make it a little better, but again, it's falling, right? It's actually going really, if you look at the trend, it's a super downtrend, right? It's going down. You might ask, hey, how this could happen? Well, there could be many factors. I said it's a new restaurant. It's the first year. They would have done an excellent marketing, right? So a lot of people would have, would like to try it for the first time. They might be actually on the prime location. So if you're in a prime location with a nice restaurant, people would like to try, right? Then maybe the food is not good. Maybe the service levels are bad. Maybe it's expensive or whatever it is. People don't like it. So they start writing that about in the online social media, Google Maps, and wherever it is, right? And then slowly you see that these reviews influence the new customers, and then it's slowly going down, isn't it? It's a negative trend. But if you look at the other restaurant, it's a story otherwise. So essentially, they might be not in the prime location. So they might be somewhere in remote locations and very decent restaurant, small one. They haven't done any marketing. So initially, they have some takers. They'll somehow figure it out. There is a new restaurant over here, and they'll start writing about it, maybe word of mouth. After some time, maybe the restaurant is really nice. It's tasty. It's affordable. So you see a lot of customers coming in. So it's a really positive trend here, right? Now, which restaurant you think will you expand? Is it A or it's B? Now it's B, isn't it? Well, now there is no confusion because last time there was someone talking about both and stuff, but now it is unanimously B, right? This very simple example demonstrates how important for you to look into the data, not just the high level numbers, right? It could be, it could give only a part of the story. You should really look into the data holistically. You should do cut and slice the data, look at from a many different perspective, do a complete thorough analysis before you take any business decision. It's not only expansion of a business, it could be even a smaller decisions you take. Your HR policies. A lot of people, converted from working from home to working from office, right? And some people have done it successfully. They have done it in a phased manner. Some people have done abruptly, right? Saying, from next week, everyone should be in the office. No excuse. That's really little harsh. I'm not questioning their decision making. They would have thought very well. What I'm trying to say is that any decision you take, big or small, has to be done holistically by looking at the data, not just your data, but also industry data, data from your competitors, and then also technology breakthroughs, disruptions. So you have to really look into a holistic way of analyzing the information before we make the decision. This simple example essentially demonstrates that it's how important looking at the data and making decisions. I'm just going to summarize this example very quickly. So essentially, this is first year. This generated a lot of data. From this data, we have come up with many ratios, business variables, performance indexes, sales, profit, and other things. We also have looked into graphs and trends. All of this is what we call it as insights. So insights is essentially a summary of the data, which is meaningful, easy to read for us to make business decisions. From these insights, we make a better decisions, and what we call that as a data-driven decisions. A data-driven decision, right? And the data-driven decisions essentially makes your business successful. So that's the flow. I'm sorry, there is something which is a problem. Let me see if I can pause it. Apologies for that. All right. So if you look at the flow of the decision making, it's from the data to insights to decision, which is data-driven decision, which ultimately leads to a business success. Okay. The goal of both data science and data analytics is to make this phase where you actually transform your data into business insights in a way that it is helpful in your decision is the goal of both data science and data analytics. Is that clear? So everything about what you're talking about, data science and data analytics, essentially is to transform the data into meaningful insights. Okay? So both are same from that perspective. I see a lot of questions. I would request you to put it in the Q&A section because it will be difficult for me to jump through your questions. So I will take all the questions at the end. Okay. Okay, so now let's talk about data science. So data science is pretty much like the goal is same. The goal is to analyze the data and come up with the insights. But how data science is different is data science is a collection of fields. It's a multidisciplinary domain, right? Essentially, it has the stats and mathematics. This is the first domain. In fact, statistics is at the core of any data analysis, right? Statistics is a very old field. It's been there for many centuries. Some of the theories we use now, including Bayes' theorem, Thomas Bayes, is formulated in 1763, which is few hundred years before. So statistics is a very old field, and it has been the field for understanding the data to make decisions, right? Even before computers, even before electricity, right? So it's really, really old field. That's a core field for data science as well. Along with that, data science also uses technology. right? When you say technology, it like programming languages, big data and stuff like that, and also something which is more important, which is machine learning. So machine learning is actually a superpower tool behind data science. The reason data science has become so popular, buzzing everywhere, both in business and academia and research and everywhere, uh, is because of the machine learning. All right. There is another bootcamp which specifically focuses on how a machine learning works, and there are also a lot of other articles available online. Right. We will take it in a separate way, but for now, machine learning and technology programming is considered as a second field in data science. And the third field is what we call as subject matter expertise, or we can also simply call as domain expertise. So this is about understanding a vertical, an industry. For example, let's say you want to design a data science model or a machine learning model which can diagnose the cancer. Cancer is one of the things which we still are fighting as a humans, right? Not very particular cure, but if you can identify the cancer earlier, the treatment can be much better. And there are a lot of ML data science models in place to already give you indication that you might get a cancer, or in even actual clinical diagnosis, where you can look at a slice of a tissue of a cancer, you can tell very quickly whether it's canceric or not, right? And that really helps you to fast track your treatment, and that's really helpful, right? In order to do this, the knowledge of only math, science, and machine learning is not enough, right? You need someone who have been working on this field for about, let's say, 15, 20 years, even more than that. He is a PhD researcher, right? A domain expert who understands about how to diagnose the cancer, be in your team. So they should be a part of your project team, which is developing a machine learning or data science model, which has a purpose of diagnosing the cancer. All right. If you talk about finance, let's say you're doing something on fraud analytics, like financial fraud analytics, basically blocking the fraudulent transactions, right? For that, you need someone who is, again, expert in this area, again, working decades of experience in fraud analytics, researching on it, and stuff like that. So these people are important for your work, right? And obviously, with a couple of years of training, you will not become a domain expertise. You can very well get the machine learning and programming part and statistics and maths. That's what is expected. But domain knowledge usually comes from outside your team. So basically, you will hire people from that domain. All these three together, your stats, math, programming, machine learning, and domain expertise together is what we call it as data science. So data science is essentially a combination of fields to deliver a solution, a predictive model, which is much, much more powerful. Because it uses machine learning, data science can actually take any kind of data, both structured and unstructured. We'll talk about it in the next slide. So in this slide, what you need to really remember is data science is basically a collection of different domains, right? Stats, maths, programming, machine learning, and domain expertise. Together is what we call it as data science, okay? Now let's go ahead and compare them. I already told you in our first discussion in the example that data science analytics both have a same goal, which is about transforming the data into insights, right? So that you can make a better decision. So definition of both will be very similar. So data analytics focus on organizing, processing data to provide business insights. Data science also does the same thing, but it's a multidisciplinary field. It uses statistical research, maths, machine learning, data analytics, computer science, essentially programming, right, to come up with the insights. What's more important is that data science, I'm going to jump to here, data type. Data analytics mostly use structured data. So when you say structured data, you're talking about data which is in tabular form. Rows and columns, you have headers and you have data, right? That's what we call it as structured data. Most of your data, which is stored in tabular files, flat files, are in your relational database management system, RDBMS, like SQL, others, all have a structured data, right? And this data is what can be consumed by a traditional data analytics or analytics related workflow. Whereas in data science, of course, it can consume structured data, but it can also consume unstructured data. So what is unstructured data? Now we're talking about all kinds of data, which is not in this format. It could be an image, it could be a video, it could be a free text, it could be even a signal, light, sound. Any of these can be converted into a digital unstructured data format that can be actually utilized as an input for data science. That's because data science uses machine learning. It can basically read any kind of distance. All your computer vision, natural language processing, all can be done, which are all unstructured data because of the power of machine learning. So that's the most important difference if you look from that perspective, right? So because of this, the scope of data analytics is, essentially it uses traditional analytics methods and techniques, uses statistical tools, right? It will also use tools like Tableau and, business intelligence tools, visualization tools. Whereas the scope of data science is macro. I mean, you can do most of the things with data science. There is no such limitation as such for data science, right? And when it comes to salary levels, right, it really depends on region to region. But of course, data analytics professionals are paid slightly less than data scientists, right? That's understandable. But the thing is, when you compare to a traditional IT professional, when you look at traditional IT jobs with a similar profile, data analytics professionals actually get at least 30% plus, all right? So data analytics are paid much higher in the market. There's no question about it. But data scientists are paid slightly even more higher because of the scope and the skill set they possess. When it comes to skills, we already discussed this. So essentially, SQL, data skills, statistical techniques, and also some of the BI tools, Tableau and all is what you need for data analytics, right? Whereas in data science, you need all of them, plus programming skills, data modeling, machine learning, advanced statistics, machine learning packages and platforms. So these are the skills you needed for data science. Okay. So this is a comprehensive comparison. I should also say, most of the business data, like I would say a rough figure of 80% of the business data is actually a structured business data. All of your customer data, your orders, your whatever you collect on a transactions, logistics, 80% plus data of the business generated, or even now is a structured data, which means most of the important business decisions can be actually made using simple data analytics techniques. When you go a little beyond that, you would like to scan the social media, you want to see reviews, video reviews, convert them to meaningful sense, you want to do something more with computer vision and stuff, then data science actually becomes useful to you, okay? All right, so any questions in this? You can put it on if all good. We will go to the next slide. Well, that's all I would like to say. And then maybe a few slides. This, you can find it anywhere. So essentially, data analytics have typical relational database management system, business intelligence tools like Tableau, Power BI, or whatever, et cetera, right? And computer data science, you need machine learning, which is very important, and also software development skill, big data and algorithm development stuff. There are some overlaps like statistical analysis and data mining and problem solving that just overlaps. You can see that. All right, so and now a very important question: which is a better choice for your career? You would have already figured out. It really depends, right? Data analytics, it's been there for at least From my knowledge, I've been working on data analytics from 2007. From my own experience, I can tell you at least 15 years plus, even more. And data science is about 6 to 7 years now. From 2016, it's actually started picking up. Okay. So data analytics is a far more mature field, and it has been here for from more than a decade and off. All right. And data science is a relatively new field. Okay. So how does it make difference from a career perspective? Because it's relatively new field, you don't find getting into a job as challenging. Reason being, most employers look for foundational knowledge in machine learning and data science, right? If you're good with basics, you could get into decent companies at the junior beginner levels, right? If you're already a senior with 15, 20 years of experience managing team and all, of course, you're looking at head of the data science center of excellence and stuff like that. Even for that, your core technical knowledge in data science, the demand for core technical knowledge is on the it's on the easy side. If you're strong in fundamentals, if you understand modeling and algorithms and deploying and all this stuff, you should be good. Whereas data analytics, being an established field, the interviews and in getting into this area is usually slightly more mature when compared to data science, right? That's one difference. Other differences, data analytics takes, if you are learning from scratch, it takes about 4 to 5 months. Whereas data science takes about 8 to 10 months. Because data science, you really have to learn Python. It itself will takes a month. And then you have to learn and master machine learning, which you need to do at least about 50 plus projects. So these things actually add up another 4 to 5 months in your timeline. All right. So it is demanding. It takes the learning period. The learning period is about 8 to 10 months. All right. Whereas data analytics is typically around 4 to 5 months, including the projects and other things. Right. And then when you look at the scope, I don't have to tell you, you would have already known. Last year itself, it's about 2.5 million jobs in data science were unfilled. When I say unfilled, it means that there is a gap of talent and the demand. So there are so many jobs in the market, millions actually, which are struggling to find people to fill. One of our candidate, I forgot her name, Danita. I spoke last week in one of the success stories. She got placed in Volvo in Australia. She moved to Australia 2 months ago. And she just finished the course with DataMites, data science. And she got placed as a data scientist or business data analyst, I think, data analytics professional in Volvo in 2 interviews. And when I asked what are the questions they are, actually, how challenging was the interview, she said this absolutely nothing because they just ask few fundamentals and they say, you're on board. So what it essentially talks about is there is a huge demand for data scientists, not enough talent pool. So it's a very good opportunity to get in. But it does require a little bit more effort in terms of getting into this. Also, data science requires more programming skills. If you're not from programming background and you're not interested, then you might actually select data analytics as a better choice as a first step, right? But if you're not afraid of learning programming, it only takes about a month to get essential knowledge of Python to do all kinds of data science modeling, okay? So those are the different perspectives, right? And then which one to choose is absolutely on you, right? If you would like to put more effort and you are ready to take challenges of learning programming, which is not tough. I have myself trained more than 15,000 people in data science and machine learning for past 6-7 years. I see most of the people get the hang of it in 6 months, 9 months, and they're ready to the market. So it is not really tough, even though you're starting from the scratch. But if you are a senior professional or you want to get into the career fast and you don't want to really get into any programming side at all, then data analytics is actually a better choice. It's also important to note that you can start your career as data analytics and add on machine learning skills, learn some more advanced statistical research methods, then you can switch to data science. That's also much smoother options to do because you don't have to really put a lot of effort in the first step. All right. So I did not really conclude anything because there is no such conclusions because both are really nice fields. It's a matter of your interest and your ambition, your career ambition, right, to decide which way to take. As I said, both are very closely related. Even if you start taking a direction towards data analytics, you can simply add on more skills and come towards data science at some point. Okay. I already mentioned how long it takes. And this is one of the often asked questions. Do you need a computer science background? I would say no. Well, there are people from computer science background. They might find the programming little. So that looks like no, right? Because whatever you learn in computer science about microprocessor and data algorithms, and the data algorithms and search algorithms and all the stuff, it isn't really relevant to data scientists or data analysts. You need a bit of programming, yes, of course, but that's all it is. That's the only overlap you have. So you really don't need a computer science background. It is not required, right? Anyone coming from mechanical background, biology, chemistry, or arts, or economics, any background, right? They can smoothly transition to data science. So if someone says computer science is kind of helps you, or it's actually kind of required, it's just a myth. I have an authority to say that because I've been training a lot of thousands of people and help them in career transition. Computer science isn't really required at all. Okay. Any degree is fine. Okay, so that's all the webinar. I have about 10 minutes to take questions. All right, and I see already there are 25 questions plus in the question answers. I will take the questions one by one. All right, so I have a question from William. The question is, for me to succeed in data analytics, I need a diploma or degree in any field. Well, as I said, any degree is fine. And some degree might be needed because most of the big companies ask for degree graduates to be coming into these fields. But having said that, a lot of things changed recently, last 5-6 years. So people are not really worried about academics. If you have decent academics, that's fine. What they're actually worried about is your skills, your attitude of learning, and their skills match with their requirements, right? So how is your attitude, both as a person as well as learning attitude, your fundamentals, and their skills match to their requirements? That's all, right? Rest all of the things do have a little bit of importance, but it's not really, it's not going to really make so much difference. So do not worry about your academic background as such. I have a question from Seda also. It says, sir, how could I pursue career in data science after non-technical background? Seda, I told you already in the webinar, I guess. Background doesn't matter. From my own experience, I see about 70% of the people who have successfully become data scientists or data analysts are not from technical background. They are not from nor IT, nor data background. So majority of the people who are moving towards data science are not from technology background. So you can confidently jump into it. I have a question from anonymous attendee. I'm from a supply chain field, and at one of my recent roles, I was required to use MySQL to extract data to make supply chain decisions. All right. This made me to realize the future supply chain will be integrated with the data field. That's of course, right? Now I want to transition into this field. What field will be better for me? So if you're into supply chain, I would say you should start looking at data analysts or data analytics. Both are very easy. So I would say data analytics will be a good field for you. A question from Jane Adbin. CGPA does not matter. I answered this question. Your academics has relatively less importance. So I repeat, it's essentially your attitude, both as a person, as a team worker, etc., etc., and then your learning attitude is what we really look at because of this changing technology domains, and your strong foundational knowledge and the match to the requirements. That's all most of the employers look in. Yeah, it's a good CGP. Shouldn't. I have a question from Jeremiah. Considering that I'm a beginner in studying data science and keeping the phase, how long it takes me to be ready for the field? Oh, okay. So if it is data science, I would say it takes about roughly 8 months to my experience. Some actually make it in 6 months, some take 10 months to a year, but that's the average, 8 months, I would say, which includes your project and internships as well. I have a question from Rahim. I'm good at coding and I want to shift to data science. So if you're good at coding, I would say you should focus on data science. That's much more. In fact, a data scientist can always work as a data analyst or data analytics professional, right? So it's a subset of it. So I would say focus on data science. I have a question from anonymous attendee. What is meant by unicorn? Oh, okay. Oh, you mean the unicorn of this diagram? I just picked up from online. It's not something I've done lately. Let me see that. Oh, okay. So this one you're talking about. All right. So this unicorn, unicorn is a mythical creature. They don't really exist. So in early days of data science, this diagram was really popular, right? Unicorn essentially means one person may not have all of these skills. So it's usually a group of people in the data science. As a data science is a multidisciplinary field, you cannot expect all the skills, especially this domain knowledge, in one person. So that's why they put a unicorn in there, okay? I didn't notice that. Okay, so that's unicorn. Jane, yeah, Python is used in data analytics. It's not really mandatory nowadays, but you can even see just like that. I'll show you. If you go to ChatGPT nowadays, all right, you can ask a lot of these things. Right? So I'm going to just ask ChatGPT. I have both 4, right? Let's go to 4 or 3. Let me stick with 3. So I can simply ask ChatGPT write something like machine learning classification model using random forest. All right. For data set iris, which is a standard flavors data set, right? And then you see the code it writes is perfect. It is flawless. You copy paste it. It works exactly the same. Now I can ask saying that, okay, now try support vector machine, SVM. Actually, what is going to use is SVC, support vector classification model. Also fine tune the hyperparameters with, let's say, grid search. I even typing mistakes over here. It shouldn't matter, but let me just hyperparameters. All right, so it's going to take the code, rewrite it with the support vector machine. So you see there is a module that's imported called as grid search CV, which is grid search cross-validation model, right? And the code is like, it has given you a bunch of parameters. The model is going to try all of this C, gamma, and kernel combination, essentially 3 cross 3 cross 3, which is 9 into 3 is 27 times. It's going to run a model with different parameters. It gives you the accuracy at the end of the day. So what I meant to tell you is that even if you are in data science, your knowledge of Python is going to be, it's not very relevant in the future. It's actually coming down. But yes, if you have a Python knowledge, you could do a little better. You can tweak and adjust things by yourself. I have a question from Mohammed. Is there any overlap in skills and tools of data analytics? Yes, the data analysis, your statistics, visual analytics tools are all overlap. In fact, data analytics can be pursued as a subset of data science, if you want to put it that way. And that won't be wrong. Data analytics can be taken as a subset of data science. So there is a lot of skills overlap. A question from Ayan, is Python only recommended programming language? Yeah, we have R, even other languages like Java also has, but Python has become ubiquitous, like everywhere. All the projects we do about, like, for me, 100% projects we are doing in Python or Python related packages like TensorFlow, PyTorch, etc., right? But we do use R in some places. It is becoming less and less. Simple answer, yeah, I think Python is good enough for most of the purposes. The question from Ranjit, route. So the question is, do we have a master's deep learning for data science? Deep learning is an extension of machine learning. We use more deeper neural algorithm, which has more than 3-4 depths. We have several models. Usually, deep learning is a basis for your computer vision and natural language processing, also GAN and other things, right? For data science, you don't need deep learning. Deep learning is used for computer vision, NLP, and those kind of works. For data science, as classical models like classification regression models is good enough. If that's a question, you don't need deep learning for data science. But if you know machine learning, learning deep learning is a small step. You should be able to do it without any difficulty. Manasa, Python isn't really required, but if you have Python, it is better in terms of writing small step data cleaning and stuff like that. Python will help you. As I said, we are getting very sophisticated tools. So all of the stuff you might do with Python can be done by you without knowing Python. So that's why I said it is not really important. For data science, yes, it is really required. For data analytics, it's optional. So Horia has a question. So unstructured data takes only 20%. Yeah, this percentage was even less 3-4 years ago. Now it is going up, right? So most of the business critical data in any company in the world as of now, even though they're stored in data lakes, they're still structured. Okay. A question from Mohammed. Can a data science professional perform the duties of data analyst? Yes, of course. That's something which often happens. People who are study data science land up in data analytics job. It's more or less they're overlapping. So it's just that they won't be doing much of machine learning there. They'll be doing the data analysis and insight part. Question from Mars. How about learning data analytics first, becoming the pro in it? Yeah, I would say yes. I already told that that's good. That's good approach. Dancy has a question. If we were new to computer language, data analytics is better for you. Amatullah has a question. Computer science, data science are different. I told you before, there is very less overlap between computer science and data science. So they are not same. ML is used as a tool for data science, right? ML has a good overlap with computer science, but in general, data science and computer science have very less overlap. The programming part is what is the overlap over there. So I have a question from, what are the market demands on data analysis, like you spoke on data science? I don't have the current numbers. It is 3.6 million. So I have just ping me on the LinkedIn. I'll send you the report from, I've looked at the World Economic Forum report. Last year, they released it. It's around 3.6 million new jobs coming into this data analytics area, which is not overlapping. It's purely on the traditional data analytics area, right? But I'll send you the report of World Economic Forum, as well as many other reports from McKinsey and Forbes. Reflects the same thing. A question from Ahmad. What's the difference between data engineer and data science? All right, it's a good question, Ahmad. So there is an entirely different bootcamp for it. But as you asked, I'm gonna quickly describe it. So if you look at data science and data analytics, data engineer and data science. So if you look at the data science project, roughly we can consider 6 phases. Phase 1 is data gathering or collecting the data. Phase 2, preparing the data, you can also say cleaning data, right? Phase 3 is enriching data. So making this data, we do feature engineering, we extract more new features from the existing data, enriching data. Phase 4 is where we actually do the data models like machine learning models and visualizations. And phase 5 is actually, let's say, deploy and maintain. So in early days, in around 2015, 2016, right? All of these are actually done by data scientists. It used to be a very cumbersome job, especially the first 2 things, which is data collection and cleaning the data, takes nearly 50% of the effort goes into the first 2 areas. And data scientists are not really specialists in doing it, right? If you look at the current days, these first 2 things actually taken by data engineers. So data engineers are masters of data management. They're very good in databases, both SQL and NoSQL databases, right? NoDB databases. Also with all the other platforms like connecting to the data lake, blob storages and stuff. They are good in the data ETL part, extract, transform, and load, right? As well as they're really good in building data pipelines. So they ensure you collect the data, create the data pipelines, make it to the format which is needed, and then it goes to data scientist. I must say, data engineer is more technical than data science. Data engineer is more technical than data science, right? And data engineer is more on the data infrastructure and maintaining pipeline. Whereas data scientist is actually on the model building. So from a career perspective, data engineering is becoming also very popular because if you can imagine any business in the world, anything you want to do in AI or data science or anything, data engineers are really important because they are the people who maintain the data. They'll make the data available to you. So more and more companies are realizing the importance of data engineering, and that is actually giving a lot of the huge growth of jobs in the market for data. Okay. I have a completely different bootcamp for data engineer versus data scientist. Yeah, we will look into that. I do have about 40 plus questions. I don't think I'll be able to answer all of them in this webinar, right? So what I'm going to do is I'm going to leave my LinkedIn profile to you guys. Please send a message to me and I'll be more than happy to. So I answer all the questions in LinkedIn on a daily basis. So I'll make sure that I'll answer all of your questions. Okay. All right. So apologies that I couldn't take. I'm just seeing if I can take up 1 or 2 questions. Most questions I have answered. You get a certificate. Everyone in this call will get a certificate. Okay. There's a question on, although there seems to be 2.5 million unfilled jobs in data science, there seems to be bias to hire young. Maybe the starting salary is determining like that. Yes, so significant jobs are for youngsters, the beginners and juniors, because there's a lot of work at the ground, requires hands-on people to actually clean it and build the models. So I would say majority of the jobs, I don't know the percentage roughly, but most of the jobs are for under 5 years experience folks from the 2.5 million. That's right. Okay. All right. Thank you very much. I hope that the webinar, the bootcamp has been useful. And if you have further questions, feel free to drop a message to DataMites. I think you have their email ID. So if you go to the website also, you can interact with them. Right. If you have any specific questions about your career, whether it fits to you, if you're a senior person, how to transition, I always tell, even if you have 15, 20 years experience, there's a lot of scope in data science domain for you, right? Even though you're not related to the technology domain, right? So if you have any specific doubts about your own career transitions, like I also mentor the senior executives. I have done a lot of senior executives, AI trainings and career transitions related questions, also business transformation consulting. You can always reach me over the LinkedIn. I'll be more than happy to help you. Okay. All right. I enjoyed the session. Thanks a lot for all the questions. I wish you all the best. Thank you, DataMites, for giving the opportunity. Thank you.